Hey, this is Dave coming at you from Southeast Michigan. We're back at the house build finally after about a year. And Justin and I have been working on the rough plumbing supply lines for the last probably week and a half. And so I'll show you what we've gotten done. Actually, probably about 2 weeks, but we've been doing pretty good because like here's my daughter's bathroom. And so what we're calling the custom glass shower people, just because this is kind of above my pay grade. I've never actually done a shower of this magnitude where it's going to have like the homemade, the PVC liner and all that. I've done a couple of those, but like basic showers. And so at first we were going to leave it in open where you just walk in, but then just with the shower pan and the way that the floor would be, it's very difficult to waterproof it properly. You can, but then it's just hard because the rubber membrane doesn't really have anywhere to go. And if you put it under the hardy backer board, now you're drilling screws through it. So Nikki, and this isn't the finished product. Because my point is we're building up a curb here. We're probably going to put 1 or 2 more 2x4s in here to make it 3, and then it might be as high as 4 inches. With the we're going to put like some type of a quartz sill there. And then what my point is, I called a custom guy, and they can build pretty much anything you want for this opening. But he said that standard glass door is like a 28-inch door. So it's done the same as like a rough opening for a door. So if this was your shower door and you want a 28, you would just rough frame this 2 inches bigger. And that makes sense because you've got the hardy backer on each side plus the tile. So tile being 3/8, but basically an inch on each side. So that made sense. So I said, well, if I make an opening like say 56, maybe 56 1/4 for play, by the time it's 56 1/4 and that's finished tile, will that work for you? And he said that would be absolutely perfect. So then I also told him about this header. And the reason why I wanted to build the header is because I wanted to drop the ceiling to keep the rain can and these shower heads out of the actual insulation. We didn't drop it that much, only about 4.5 inches, but we dropped it just enough to get those pipes. Even though they're not pressurized, it's you get a really cold day and some of that water that's just resting in the pipe after you're done showering could freeze. And I just didn't really want any of that. So that's what we did. So let me just kind of walk through, but yeah, there was some planning and just like I called the Hodges Plumbing Supply, which have been really good because, I'm a guy that's walking in that doesn't really know a whole lot about the shower valves and all that stuff. I know a lot more now than I did when I first started this, but basically here's my daughter's shower and we got these cool like test plugs in here, but the way that this works, there's some videos that there's just not a lot of information out there. And so maybe I could help a little bit on conveying some of the stuff that I found because some of it's just hard to find. But anyways, this is the mixing valve. And by the way, Delta is a really good brand. They've been around for years. And one thing I loved about Delta, which made me decide to go with them, is that this is just called a multi-choice mixing valve. It's a valve body, and then it's got the cartridge that goes in after the, in the finish stage. But like at the big box stores, you have to buy this all together with the finished trims, aged bronze or brushed nickel or stainless steel. And I didn't like that because Nikki and I really don't know exactly what colors we want in here yet. And he says, well, why don't you get these multi-choice and you can just put anything you want. They just all go in here. And then the standard here, he said about the distance between them, like 8 inches. I think we ended up going like more like a 10-inch. I don't want the 2 rings. This ring will be smaller than this one, but this looks about good from all the pictures I've seen and just measurements I've read. But anyways, the way that this works, you have and this is a high flow valve too, so there's a little bit more water that will flow through it. This is cold, this is hot. It mixes it. It goes up into the diverter, and then you can do a 3-way function or a 6-way function. And that doesn't mean that these aren't 3 functions. Right now we have this set up as a 6 function, even though you're only using 3 pipes. And the way it works is it's like a 6 peg dial. The first dial being only the standard shower head works. The second dial, these 2 work, and that'll be like a rain can that comes off the ceiling. And then I believe the third function is only this. And then the second function is both of this. Or I guess that would be the 4th function now. 1, 2, 3. And then it goes 4, 5, and then 6, I believe. You get 6 functions. You get 6 functions from 3 pipes, and then you get 3 functions from 2 pipes. So we were originally just going to do the 2 functions, which would be, or the 2 pipes being 3, I guess, functions. You cap this one off, and so the 3 functions would be this one, then both, or this one. So we just decided to add another back shower just because it's open studded, and I already paid the $100 for the diverter valve. So I just wanted to use the last function here. It just seemed like it made sense, and this is a big enough. So this is what we did, and a lot of people, like my friend Matt, teased me a little bit, which is fine, but we Craig jig all our blocks. And what this did is it makes it to where once we have everything set, we just take the screws back out, pull this off. You can solder all of that without even really messing with anything. And then when you screw the holes back, the screws just find the same holes. Another thing that's standard that a lot of people are, the way that these valves are designed from Delta specifically, this wall got furred out 1.5 inches, so it's hard to show an example from this. But these valves will work if you don't want to overthink the depth. If you're just doing something like a 1/2 inch board, which is very common, and then 3/8 tile, that would, in my opinion, be the most common thing you're doing in a custom shower. You figure it about 1 inch, because by the time you got the mortar build up, you're going to have 1/2 inch hardy backer plus 1/2 inch tile. And this right here gets finished to that. But if you're not wanting to overthink it and really, like what we did is we ended up cutting a piece of wood that just spanned across here that mimicked that 1 inch, and then set the block to that. But the way that these valves are designed, in a standard 2x4 wall, which is that's what you're going to have most of, you just put this 1.5 inch block flush to the back of it. What we found is you're flush to the back, because we do have the one in my shower that's a 2x4 wall. We found that it almost lines up better with this flush if you're literally like just 1/8 inch inside the wall from the back. So if you're at the back flush on a 2x4 wall, or 1/8 inch in, that's where you want to be. That's that. And it took me a little bit to figure out that stuff. And then my friend Matt was talking about like a linear drain here. I haven't committed to this yet. And I kind of like that idea, because then it's easier to slope the dry pack for all of that before, like the pre-slope and all that stuff that goes involved with this. And it's called a mono slope, where instead of having the slope come in and you're trying to trowel around, and then a lot of times with that, I've noticed that your corners tend to like level off. So you got to make sure you build that all the way up to the point. The mono slope makes it to where you have the trough drain, even if you have like a 224s, you just do that mono slope where it's troweled all the way down, this being your high side. I haven't decided yet. Oh, and then that takes you away from not having to use mosaics, but I would push back on that a little bit, because even if you put the trough drains here and you have a nice smooth slope, you're going to still have an upslope on the back, or you're going to have some funky stuff going on there, but it's going to level off, in other words. So if you did do bigger tiles, you'd still have a problem in the back trying to get that to slope out. So I would still say you'd want to use smaller tiles, even with a linear drain and a mono slope, to do that. But anyways, let me keep going. We have, all the stub ups are done. And when you're running pipes, whoa, that ladder just has a mind of its own. It just shifted. But when you're running any pipe work, and even with like electrical wires, you kind of do it the same way. You're in the first floor of the main house or the second floor. You want to basically just don't worry about anything except like, I have a sink here. I need a hot and cold. I need to stub the pipes down. That's it. So we just found out, like, let's stub it down like maybe 1 inch lower than the center of the joist. So all these are basically like 28-inch stubs. We just pre-solder them ahead of time, stub them down. That's all you have to do. You don't even have to worry about anything else. And then, like, here's the laundry we got done. I was actually just able to sneak those in with some 45s, but there's that. A lot of people aren't wanting to use copper anymore. They want to do the PEX, and it is a little bit more money, but man, it's just so satisfying, and it just looks so good when you have the copper in. What else here? But yeah, you have to just systematically, a lot of times, an overwhelming job. I've been on jobs where it's like, where do we even start? And just with my experience, you just start with the stuff that you absolutely know and that you can do. And then as you keep building off of that, you start kind of figuring it out. Here's a little, this is what Justin and I worked on yesterday. The print, I don't know exactly where it is. Our house build print's correct. Obviously, we built the house this dimension. But the print we turned into the kitchen store, the KSI store, somehow it might have been me, it might have been the lady at the store, it might have been my wife, it doesn't really matter, but they gave them the measurement of like 174. This is actually 186. So what that ended up doing is it made it to where my HVAC guy put the valve all the way to the right of my 4-foot oven. And just that small space, this before yesterday was here, we had to move this. And so that means that we have to take it all the way off back to there. We ran it back down. There's actually his old hole. We recapped in the notch he cut out of the drywall backer. So we got that done. And then this marks the center of our stove at 4 feet center. And so we built Leah's niche there. I didn't show you. And yeah, we also Craig jigged. My friend Matt rolled his eyes when he saw that. I'm like, you like my Craig jig, Matt? We're Craig jigging over here. But anyways, we put a pot filler in here so that way we centered it right on, Nikki's going to have like the 4 burners here on the stove. And then on this, think of this stove as like 12 inches, 12 inches, 12 inches, 12 inches, like just 1 foot segments. Here's the center. This is going to be like a waffle, some type of griddle thing. This will have 2 burners, which will probably be off limits to the pot filler. But then you're going to have the 4 burners on this side that this is kind of dead center. That's why we notched this, because I wanted this to come out right at dead center of the oven. Nikki, it's important to her that she wanted like the oven to be centered of where like the fireplace is going to go. And then at first we were really messing with wanting to center this, but then with Leah's niche right here, we decided that it's just probably better if we just centered that hole right on these burners. And then the way that this thing, it slinkies out, this arm swings back, the first arm, and then there's another arm on that about 4 inches higher that swings out, so it comes way out. So when this is slinked back, it'll be sitting more from here to like say here, so it's going to center a little bit in there. It won't be perfectly centered in there, but what are you going to do? And we did like a little bit 4-point saddle. The only burn mark we have on this entire job on this one is just a little bit right there. But we were able to like pre-solder stuff, and then the way that we got this pipe in, we drilled a little bit bigger holes. And this is another tip I could give some plumbers that are using copper. Whenever you have an outside wall, we just drilled a hole out the outside, and we just shoved the whole 10-foot stick of pipe right in through the back of this wall. We couldn't go down here. Excuse me. This has a 14-inch LVL here, and then a 2x12 here for that lower floor drop. So this bottom plate is no man's land. So then we just got out of there and dropped it. So then yesterday, yeah, we did that. We did this, moved the gas line. We've got, this video is going to be a little bit longer, but I'll try to. And then at the end of the day, we just got these copper pipes. We haven't even put them in there yet. Drilled through here, got the supports up. And we got these. I've noticed when I do my videos, I'm always hanging it down too low. I'm going to try my best to get some epic shots here. But we just decided to get these. These are the 2 3/4 that are going to feed this upstairs bathroom here. We've got the stub outs here. Like I said, once you get your stub outs, don't think about anything else. You get them down here, and then now we know that that's a cold, that's a hot, that's a cold for the toilet. And so we can kind of see how it's starting to come together, and then you just piece it in from there. And then we're also going to have the hot pipe, which is this one on the left. It's going to come this way. And Justin actually came with a good idea, because I originally was wanting to come down this wall, but it's terrible in the basement for that. It's awful. So he's like, well, why don't we just come down all the way and stay in the ceiling here, come through here. This will be a 3/4 inch copper. This is the return loop to the circulator pump. And it's going to just come through here and just drop down in this same wall that this drain for the upstairs furnace is in. And I like that, because when you come down through here, you have a nice open area in the basement. There's a lot of mechanics. So anyways, there's that. So that's what I'm going to try to do, a little bit of that work today. I just got here. It's Saturday. I figured I got everything done at home, so I might as well come and do some plumbing. So then we got, this is this bathroom here. We got the plumbing in here. All the way from here is no man's land. This is all that cold air return goes all big old main cold air return, and it turns this way. So we had to come from here. We stubbed them a little bit lower. They say 20 inches off the floor, but sometimes in a case like this, you just can't really do it. So it's fine. That's going to land right where we need it. Then we've got this these valves in, or this is another delta valve, but oh, here, this is a good example. Literally just an 1/8 inch inside, but it's okay. The directions say that this is where you want it, right on the back, give or take a 1/4 inch that way or this way. They have that 1/4 inch plate each way. And that's information that I was having a hard time finding on that. What's the proper depth to a delta valve? And so now you guys know. So then this is where we worked for a few days in our master bath. We got these. Ooh. And that's another thing. Before you solder in the basement, these just got knocked around. You want to keep them square, and then right before you go down to solder the system down there, just make sure they're square. Make sure that they're at the height you want. Then you can solder. Got these two in for this sink because we have a double sink. We've got and then this right here I put at 7.5 off the hardy backer. By the time the tile's in, you're going to be at about 7 1/4, 7 1/8. That is in case you want to go with the 5 1/4 base molding. You don't ever want a situation where your toilet pipe or any pipes are stubbing out right into your trim. It's awful. You don't want that. Okay, so then we framed this one in, this shower, and since it's a smaller shower, we just decided to go with that one single measurement of the 28. So we roughed this in at 30 1/4, 2 inches of play for the hardy backer and tile. And then I love just adding that little 1/4 inch. It always helps because in the real world, liquid nails, things aren't level. You might take up that 1/4 inch. So he said don't make it any smaller than 28 inches finish to finish tile. So 30 1/4 rough opening will accomplish that. So then my friend Matt gave me a good idea. He said, a lot of people, and he was right because I was thinking of this too. We're so used to growing up in a bathtub where you got a shower valve and then the header right above that we don't think that those rules can be broken. And so I was thinking, well, I'm going to have my valve here in the center, and where am I going to put my diverter? I want my niche in here, and I don't want to do a niche in the exterior wall because I want that fully insulated. And then we didn't plan on it. We actually have this damn pipe. I would have probably done something different, but having this over here and jogging it, but I just wasn't thinking in terms of, I knew I was going to have the shower valve over here. So originally we were just going to do a basic head until I really learned about how this stuff works. But this one, all we did is we just have the diverter valve, instead of being at like a 48 inches, we dropped, the mixing valve, cold, hot. We just put them left to right equally. So what we have here is we've got the mixing valve, it comes up and over, and I know that's a little crooked, it bothers me, but it was the way that shifted, it just needed to be a little off. But anyways, it mixes the water, comes up over to the bottom of the valve, and then we got the 3 functions. This one comes up over around the niche because we built a niche here. Niche, go for it, whatever you want. And then up here this way, that, and then this one comes off, goes up and around to the rain can. This one was the one that took us a little time because it was just a lot of plumbing, and this comes up, drops back 45, stays level with this because I thought it would look better. Comes in, drops way down and around and behind. Notice no burn marks, nothing. We actually planned it to where it was kind of figuring out a puzzle. What do we do? Put a block in first? Do we pre-solder this? So that's kind of, you just have to kind of, figure it out. You can do a lot of this stuff without burn marks if you really plan it. So it just comes down to here, shower valve, or these are going to be like, they call them sprayers. They're not jets. They don't jet out like a whirlpool. We just put them in because I'm a nerd, man. My main reason, I wanted to use the 3rd function, but I also have never plumbed in something called a pressure equalization loop. And what that basically means is when you have the 3 functions, as long as one function is coming off of each pipe, that's fine. And it just goes there. And then this will go and hit that. Since this is a longer distance than that one, hydromechanics just tells you that maybe this one will have slightly less pressure than that one, because it'll be like if you're functioning these at the same time, but not enough to notice. But then on this, you have more than one head on one pipe like that. If you were to just do them in series, the 4th one will have less pressure coming out because it's the furthest away from the diverter. Not only is it the furthest one away, it would be, what am I trying to say? It's the furthest one away, but it's the 3 ahead of it have already gotten their water. So not only is it the furthest one away, it's the last one to get the water, that whatever's left over. So what you do is we ran it up and over, and it just takes double the pipe. We just came up, ran it over, up. We had to set more blocks up there. I guess we should strap that there too, but whatever, little loose end. That comes up, down, T's here, another sprayer, and then this is the loop. This is the equalization loop, and it comes back and around. So basically what that does is it makes it to where when this turns on, it just forces the water to go this way and this way. It fills the entire pipe up, and then what it does is it makes it to where all the water just comes out equally in all the sprayers, because it's equal at that point. You have a equalization pressure loop is what it's called. And back to me being a nerd, I've just never plumbed in a pressure equalization loop, and I wanted to just challenge myself and do it. Another thing that the guy at the supply house told me is be careful about having all sprayers up higher, because what will happen is if you don't use this very often, let's say you're just using your standard head and you just get used to it, and then like 6 months goes by, you might start smelling a funky smell from your well water, because if these are like higher up than the valve, when you turn it off, this pipe will just stay filled with stagnant water. So basically we got these. I wanted these higher up, but with that in mind, I know that you can turn it on, and this is the idea of stagnant water. It was creeping me out a little bit. So basically I just made sure that this was a little bit lower. So now when this valve gets turned to the other ones and this isn't used, the only stagnant water that would be in this pipe would be just from here to here. That's it. And there's not really a whole lot you can do about that. You could come down lower, and then these would have been lower. So that's fine, man. You're dealing with 6 inches of water. You're overthinking that at that point if you think you're going to catch some like disease from that not being turned on when there's just that little water there. But the way that this is piped now, if you do turn this off, the water just naturally drains out here, drains out here, drains out here. And then at least this system, this will just drain out, just being, even though it's level, it'll all drain out. So now we're literally at probably like the longest video I've ever made. And then with this, the Roman fills that go in here, we're going to put like an 1 3/8 finished countertop material here. We decided to cut a big hole right here. And what this hole does, because the stems of the Roman faucets only say that they have thickness of 2.5 inches to get that nut on the bottom. And since I've already got, what is that, 1.5 inches plus 3/4, 2.25. I already have 2.25 there, but by the time I add an 1 3/8, I'm going to be way past, I wouldn't even be able to get the nut on. So I've never seen this. There's no videos that you can find on it. I don't know what's going on, but my friend Matt saw this, and he's a builder. He's been around a lot, and he says he thinks that that's a good idea. Just completely cut a big old ugly hole in there, and then we just decided to cut a big hole down to the basement, and that way you have access to work on this. And what this actually does, having that hole there, and there will be fire stopping we have to deal with here. I'm aware of like fire stopping there, but this makes it to where we can just tile this. And I am not having an attic access. I'm not having a spa tub access here. They do say it's code that you want an access back by these motors right here. But look at the way that this is built. And I don't want to argue with an inspector, but I'm not planning on putting a panel here. I'm going to drywall this, because now that I've messed with these tubs a decent amount, we've had this in and out probably 5-10 times, because it's just with finagling and getting things right. Me and Justin can pull this tub out of this hole easily. So let's just say that you have something that starts leaking in the back. Well, you're not going to use this access hole to fix something back there. I wouldn't even want to use a hole here to pull these motors out. It's just very difficult to get in there. You got to lay on your stomach and get in there. So my whole point to my rant with this is, I think that it's easier. The only thing holding this tub in when it's finished is literally the drains hooked to it. With it, you've got like the bottom part and then the vent and the overfill. That's easy to take off. And then you have to unplug it from the plug that's going to be in here, and then cut the caulk line that's around your tub, or around the countertop material, the quartz material, and you can just lift this whole thing out. So I'm just going to tell the inspector, anything that ever goes wrong with this tub, it's actually easier just to pull the tub out of the hole and just work on it out here. It just is. Now that I've messed with this enough, I'm just looking at this going, if I was a tub guy that was fixing jacuzzi tubs, I would be like, ma'am, do you mind if I pull your tub out of the hole? I mean, it's just easier that way. But anyways, that's where we're at with the job. We're just going to keep going on, and then we're going to be getting into, once, like I said, the systematic of stubbing everything down. We felt that the next step is, now that we've gotten everything stubbed down, this upstairs isn't in the basement yet, so we're kind of looking at this as a stub down. So once this all gets stubbed down with the hot and cold here, which they are stubbed down, but you know, get those tied in, we're gonna have these stubbed down, and then and then we'll just have the one return loop for the circulator pump stubbed down here. Once those are stubbed down, we're pretty much ready to start doing the main. And the way that we design this main here, it's gonna have an 1.25 inch line that just starts from down here, the water pump, the expansion tank, and the water softener is going to be right here in the basement, in this utility room, in this triangle room, Leah's workout room. You're gonna have the water come in on this line right here, probably well in this area. We're gonna come around, coming through the basement, expansion tank here, water softener, maybe an iron remover, whatever the test says that we need. And then from here, it's going to be an 1.25 inch main. And the 1.25 inch is going to start from here, and it just runs right down through the main, all the way through here. And there's a water heater all the way at the end. So to do the plumbing test, to test it with the pressure, so we pass the inspection, we're just for now going to run the 1.25 inch here down in the basement, probably about 3 feet past that wall, just so we know we have enough to turn. We're just going to put a cap on this, and that's it. And then we're going to start running it. And we have like 4 outside spigots that are going on this house. So the biggest thing is, once you get all your stub downs done in any system, whether it's vent, electrical, plumbing, anything you're doing, air lines, once you get all the stubs down, you just got to just keep going and putting your T's, and everything's going to branch out, keep going, branch out. Some of them are going to have shut-off valves. Some of them won't. And you just, when you're down there, the biggest thing is you just don't want to forget anything that you're putting in that system. So what we did, this is a rough draft, but when I get down there, I'll go home and really do it. We just did a little drawing like this. It show you like water comes in, like I just showed you. You've got like the expansion tank, water softener, and then 1.25 inch goes to here. And then these are all the things that will tie into that. And so right here, I'll show you physically where that's at. I'll walk to it. This is 1.25 inch just to take care of the load of the house, because when I did the load calculations for the water quantity that you need, it said 1.25 inch by just a few fixtures, maybe about 20 fixture units, which is quite a bit. And once we get here, it drops from 1 inch. So right there, you're going to have 1.25 inch copper from here running down through the center, because we figured full bathroom with all the bells and whistles here, tub, shower, full bath here with the sink. You've got this guest bathroom. Then you've got the pot filler. You've got the kitchen sink, the dishwasher, the ice maker for this fridge, and then the laundry's running. That's a lot of stuff. That's like a full house usually. And so 1.25 inch here, but you still have tons of stuff going on downstream, but not enough to warrant an 1.25 inch pipe. That would be overkill. Plus they're like $80 to $90 a piece for 10 feet. So we just decided, once we get past this laundry wall, drop it down to a 1 inch, and then immediately just put a 1 inch shutoff valve. And all that shutoff valve does is it just isolates your system a little bit, to where if you had something go wrong, let's say you had something go wrong down here and you didn't have a proper shutoff valve, or it's just something that you need to shut the water off, you could at least shut this valve off here, and still at least Leah could use her bathroom, Nikki could use the kitchen and stuff. Like we could still use the laundry room, but you wouldn't, you know what I mean? That's why you just throw a shutoff valve. And obviously you're not going to want to buy an 1.25 inch shutoff valve, because those are expensive, and then drop down. We're going to drop down, and then we're going to buy a 1 inch valve. And that's more just for, economic reasons. But yeah, that's it. I'm going to just keep doing it. And then another little quick tip, a lot of people don't realize, but when you solder this stuff, make sure that after you're done soldering, everyone puts a little bit too much solder in, because you want to make sure it's soldered. Have gloves on, take your back index finger, you just solder it in. Don't put too much heat. You'll know as soon as that starts sucking in solder, pull your torch off, you're soldering it. We all put a little bit too much in it, except for people who are doing it for years and all they do is plumbing. but we're always gonna put a little bit too much solder in there than we'd want to. It'll create like a little ball bead at the bottom. Just take your finger with a glove, knock that off, knock it off a couple times, and then just wipe it with your finger with a glove. And then once it cools down, it's very important, wipe off the additional flux you'll have additional flux that's like 3-4 inches down the pipe. Just wipe it off with a dry rag. That's why we have these. You don't want the flux sitting on the pipe because it does have like an acidic thing to it, and it will kind of it's just not good to have a lot of flux sitting on the pipes once you're soldered up. But anyways, I'm gonna keep doing these videos on this stuff. This is the stuff that makes me excited, man. I love the idea, like with this pot filler, it was just a puzzle to figure out how everything needs to go with the dimensions of what we want, how to not burn our wood like crazy. I saw this instructional video on YouTube that was funny. This guy's doing the shower valve and he's got the whole stud just burning, and I'm like, man, I don't know if that's a how-to video, more like how not to do video. But anyways, yeah, I didn't want to be that guy. I don't want to be like, I'm not a pyromaniac when it comes to doing the soldering, I guess. But anyways, I've rambled on for a good half hour now, and I'm sure that that's good for everybody. So this is Dave signing off.